So today we will learn operator grammar. First of all, we need to understand what kind of questions are asked in operator grammar so we can solve its questions. So these are the type of questions asked. Draw the operator precedence table for the following grammar. Consider the following operator grammar. We have to consider this grammar and we have to construct operator precedence relation table and operator precedence function table. These are the two things we need to learn, relation table and function table. And the third thing we need to learn is we need to check whether the given grammar is operator precedence or not. We will get a grammar like this and we have to check if it is operator precedence or not. So what is an operator grammar? Operator grammar is a context-free grammar. This is the definition. Operator grammar is a context-free grammar which satisfies these two rules. So the first rule is there should be no production which is empty on the right hand side, which has empty right hand side. There should be no production which has an empty right hand side. For example, this is a production. S derives A, S, B or epsilon. This is the left hand side, LHS, and this one is the right hand side, RHS. In this, there is a symbol called epsilon. Epsilon symbol. Epsilon is also called as the null symbol. So therefore, there is a null production in this grammar. And since there is a null production in this grammar, it is not an operator grammar. Because for having an operator grammar, there should be no production which has an empty right hand side or null production. If there is a production on the right hand side which is empty, it is a null production, therefore it is not an operator grammar. The second rule for operator grammar is that there should be no two adjacent non-terminals. Now to understand this, first we need to understand what do we mean by terminals and what do we mean by non-terminals. So terminals are anything that has an end and non-terminal is something that is derived. So terminals could be like A, B, plus, minus, comma, star, ID. All of these have an end. We cannot derive anything from this and therefore we call this terminals. Non-terminals are like capital A, capital B, capital S, capital L, etc. We call these non-terminals because, for example, in this grammar, we can derive this S using this S. These can be derived. They do not have an end and therefore they do not terminate. We call it non-terminals. All these capital letters are non-terminals. All these small letters and operators are all called as terminals. Now the rule says that there should be no two adjacent non-terminals in its right hand side. So let us consider a grammar. In this grammar, there is capital A, capital B or small a, capital A or capital B, capital C. This one is the left hand side, but we only have to check the right hand side, this one. So in the right hand side, this one is a non-terminal. This one is a non-terminal. This one is a terminal. This one is a non-terminal. This one is a non-terminal. This one is a non-terminal. So in this, these two non-terminals are adjacent to each other. They are besides each other in the right hand side. These two non-terminals are also adjacent to each other. So therefore this is not an operator grammar, because to have an operator grammar, there should be no two adjacent non-terminals on the right hand side. So when there is no epsilon symbol and there are no adjacent non-terminals on the right hand side, these two things should not be there in a production, and then we can call it an operator grammar. So that is how an operator grammar works. Now to create an operator grammar, let us start with an example, a simple example. So we can consider a simple example, this one. E derives E plus E, E star E, ID. So E derives E plus E, E star E, ID. Now how to create an operator precedence relation table. So first we will solve how to create a relation table. In relation table, first we have to break the above production and we have to find all the operators and terminals. So plus is a terminal symbol, star is a terminal symbol, ID is a terminal symbol. And then we have to add an extra terminal symbol which is dollar. Now we have to create a table. So let us create a table. In this table, we have to include all of the symbols. These symbols are plus, star, ID and dollar. So plus, star, ID and dollar. Now let's create the first column, plus, star, ID and there will be dollar in the last column. Plus, star, ID and dollar. Similarly, we have to create rows, plus, star, ID and dollar, plus, star, ID and dollar. Now this is right hand side and above this is left hand side. So this is left hand side, this is right hand side. Now in between plus and plus, we need to understand there is a rule called as left associative. Left associative means that okay, so this is not correct. There should be, this is the left hand side and this is right hand side. This is right, this is on the left. So there is a rule called as left associative, which means if we see E plus A plus B, in this we will solve this equation first and then we will solve this equation because this is on the left side. So in between plus and plus, the left plus has a higher precedence over the plus on the right side, and that is why the plus will have a higher priority. Now if we see an equation E star A plus B, in this case star has a higher precedence. Star has a higher precedence over plus. Now there is a hierarchy which says open bracket has the highest precedence, then there is ID or any operator like A, below that there is star and division symbol. Both of these have same precedence, but the one on the left side will always have a higher precedence over the right side. And then there is plus and minus. Both of these have the same precedence. Precedence means priority, so both of them have same priority. And then there is dollar at the last. So in between plus and plus, this plus is on the left side and this plus is on the right side. So in between plus and plus, the left plus will have a higher precedence over right plus. So this is how it will look like. Now in between plus and star, in between plus and star, this plus is on the left hand side, this star is on the right hand side. So therefore star will have a higher precedence. Now this plus is on the left hand side, ID is on the right hand side, and we know that ID or any operator has a higher precedence over plus. So therefore ID has a higher precedence. This is how it will look like. Now plus is on the left hand side, dollar is on the right hand side. We know that dollar has the lowest precedence and plus has the higher precedence. So therefore plus will have a higher precedence like this. Now in case of dollar, dollar will always have lower precedence. In between these two dollars there will be equal precedence. Now star is on the left hand side, plus is on the right hand side. Star has a higher precedence because we know that star is above plus, so star has a higher precedence. In between star and star, there is star on the left hand side and there is star on the right hand side. So left star will have a higher precedence. Now there is star on the left hand side and there is ID on the right hand side. ID always has a higher precedence. This is ID, so it will always have a higher precedence. So this is how it will look like. Now ID is on the left hand side, plus is on the right hand side. ID always has the highest precedence, so it will look like this. Now ID is on the left hand side, star is on the right hand side. ID always has the highest precedence, so it will look like this. Now ID is on the left hand side, ID is again on the right hand side, but both of these will always have the same priority because these are operands, these are not operators, so this will have an equal symbol. Now dollar always has the lowest precedence, so it will look like this. This is how you create an operator precedence relation table. Suppose there was an open bracket, so open bracket will always have a higher priority, so it will look like this. And if there was a close bracket will always have a lower priority, so it will look like this. Now how to create an operator precedence function table? This was relation table. This was operator precedence relation table. Now we need to create operator precedence function table. So how do we create a function table? To create a function table, first you need this table. So let us copy this table and let's paste it right here. Now you need to create a graph for an operator precedence function table. So we have to create f id, f plus, f star, f dollar, and then there is gid, g plus, g star, and g dollar. Circle each one of them. So each one of them will become a node. All of these are nodes. Now there is plus, and then there is plus on the left hand side, and then there is plus on the right hand side. Now in between this, if you look at this, left hand side is f and right hand side is g. Now if you look at the first plus, this is f plus, and this one is the g plus. Now we can see that the arrow goes from plus from the left hand side to plus on the right hand side. So there is plus and there is plus. This left hand side is f plus and this right hand side is g plus. In between them there is this arrow, you can see from the table. So it goes from plus to g. So you need to take an arrow from plus to g like this. Like this. This is how the arrow looks like. Now let us create one more edge. This is f star. So this is f star. And this is g plus. So this is g plus. In between star and plus, there is this symbol which goes from star to g plus. So f star will go to g plus like this. Like this. Let us try with another one. This is FID. So this is FID and this is F plus. G plus. Everything on the top is G. So between FID and G plus there is this symbol, which means FID goes to G plus. So FID goes to G plus, G plus, this one, like this. Now let us try with F dollar. This is F dollar, F dollar, and this is G plus, G plus. So F dollar and G plus has this symbol, which means G plus goes to F dollar. So G plus will go to F dollar like this. Similarly, we have to write for all other functions. So let us consider F plus from here, F plus, and this is G star. In between F plus and G star there is this symbol, which is this one, which means G star is going with this arrow to F plus. So G star is going to F plus with this arrow. Now next one, let us take F star and let us take G star. So in F star and G star there is this arrow. Again, let us take F star and let us take ID, which is GID. In between F star and GID there is this arrow. Now let us take F star. Let us take dollar, which is G dollar. Between G dollar and F star there is this symbol, this one. So you can see F star is going to G star. So F star needs to go to G star like this. Now F star is also going to G dollar. So F star needs to go to G dollar like this. Now here G dollar is going to F star like this. So GID is going to F star like this. So GID is going to F star like this. Now let us draw more edges. For FID on the left hand side and G star on the right hand side. In between them there is this symbol, which is this one. There is FID on the left hand side and there is GID on the right hand side. And in between them there is equal symbol. So nothing needs to be done here. There is FID on the left hand side and there is G dollar on the right hand side. And in between them there is this symbol. So FID goes to G star. FID needs to go to G star like this. FID needs to go to G dollar. FID needs to go to G dollar like this. Now let us do F dollar. This is F dollar and this is G star. In between F dollar and G star there is this symbol. Again there is F dollar and then there is GID. In between F dollar and GID there is this symbol. And between F dollar and G dollar there is equal to symbol. So we don't need to do anything there. G star goes to F dollar. So let us take G star to F dollar. GID goes to F dollar. So GID goes to F dollar like this. This is how you need to create this graph. And after you create this graph, you need to create another table like this. So another table will look like this. In this table you have to write F, you have to write G, and you have to write all the symbols ID, plus, star and dollar. Now in this you have to fill in different numbers in this table. So how do you fill in the numbers? For FID you have to count in the longest path for FID. So if you look at FID, FID goes to, let us count the longest path. FID goes to G plus, right? And then G plus goes to F dollar. So there are two edges, so we have to write 2. Now FID goes to G star and G star goes to F dollar. So again there are two edges. Now FID directly goes to G dollar, so there is one edge, right? Now FID goes to G star. Now G star goes to F plus. There is a line that goes from G star to F plus. F plus goes to, you can see F plus goes to G plus like this right here, and then G plus is going to F dollar. Now there are 4 different edges. So we have a path that goes to F dollar. We just need to reach at dollar sign at the last. So there is one path which has 2 edges, there is another path which has 2 edges, there is another path which has 1 edge, and there is another path which has 4 edges. We have to choose that path which has the highest number of edges. So this path has 4 edges, highest number of edges. So we will write our answer as 4. Now let us look at F plus. F plus goes to G plus and G plus goes to F dollar. So there are 2 edges. Now F plus does not go anywhere else. You can see F plus does not go to any other edge. So therefore the answer is 2, because this is the longest path to dollar symbol. Let us count another one. Now F star. If you look at F star goes to G plus and G plus goes to G F dollar. So there is 2 number of paths. Now we can look at another path where we have F star that goes to G star, and G star goes to F plus goes to G plus, and G plus goes to F dollar. Now there are 4 different edges, right? You can see 1, 2, 3 and 4. We took 4 different paths to find F dollar. So this is the longest path. So we can write 4 here. Now in case of dollar, there is no path going from dollar to anywhere else. So answer will always be 0 for dollar. Now let us look at GID. Let us start with GID. GID goes to F dollar directly. So there is one path. Again, the second path is it goes to F star goes to G star, so 2, G star goes to F plus, so 3, and F plus goes to G dollar. So F plus is going to, it goes to G plus, sorry, F plus. Now F plus goes to G plus and G plus goes to F dollar. Now you can see there are 5 different paths. Let us count again. 1, 2, 3, 4, 5. There are 5 different paths. So this is the longest path we have for GID. So answer will be 5. Now let us look at another example with G plus. So let us look for G plus. This is G plus. Now G plus can directly go to F dollar. So there is one path. And you can see this line is coming to G plus, this line is coming to G plus, this line is coming to G plus. So there is only one line that goes to F dollar. So 1 is the longest path we have. Now let us look at G star. G star. You can see that G star directly goes to F dollar. So there is one edge, one longest path. There is another path that goes to F plus, then F plus goes to G plus, and then G plus goes to F dollar. So there are 3 different lines. So 3 is the highest number. So therefore the answer is 3. So this is how you write the operator function table. This is the operator function table. You can see that ID has 4 and 5. This is the highest value that it has, because ID has the highest precedence. you can see that star has 4 and 3, which is the second highest value, because star has a higher precedence than plus and dollar, but it has lower precedence than ID. Now plus has 2 and 1, which is higher than dollar symbol values, which means that plus has a higher precedence than dollar, and dollar has 0, which is the lowest precedence ever. And this is how you create an operator function table. This is called as the function table. Thanks for watching.